All right, so this is an example of a problem that is kind of difficult unless you kind of see what to do. So it's really useful in a problem like this to know, I guess, like the short way to square something. So, like for instance, if you had x plus y squared, instead of having to do FOIL, if we just know that it's x squared plus 2xy plus y squared, and then we know it even more generally as the first thing squared plus 2 times both of these multiplied together plus the second one squared, we might see that this 9x squared plus 12xy plus 4y squared is just this squared because 3x squared is the 9x squared and 2y squared is the 4y squared. And when we multiply them together, we get 6xy. And when we double that, that's what this is saying to do, we get 12xy. So all this is, the thing that we're looking for, is just the left side squared. So it basically comes down to what you do to one side, you do to the other. So then this is all just going to equal positive 49. So that's the answer. Just positive 49. And nothing else to do. But it's again, it's a hard problem because if you don't see that, it's kind of difficult to do. Okay. Any questions on that one? Cool. All right, let's try this one. All right. So they want this in the form of ax to the b. And then eventually A times B. So to get it to look like this, I'm not really, sometimes this gets confusing for students, but I'm not really gonna, I'm only gonna use this to guide the fact that I want everything in exponential form as opposed to radical form. So I'm gonna rewrite all of this in exponential form and then kind of go from there. So I have a 10, which is nothing's really happening to it. And the way we turn something into exponential form is, for example, let's say we had like x to the, I'll use different letters than a and b, like c over d. A rational exponent, the numerator is the power and the denominator is the root. All right, so if I take this 9, for instance, this 9 is being raised to the third power and then we're taking the sixth root of it. So it becomes 9 to the 3 over 6. And then we have the same thing with the x. That's to the 48 over 6. And then on the bottom, I have 6 to the 4 over 4. And x, this is an imaginary 1. So that's x to the 1 over 4. Now, again, I'm just really explaining all the concepts. A lot of this you might have been able to just do in your head. So this is 10. This reduces to 1/2. We should know that the 1/2 power is the square root. So this is the square root of 9, which is really 3. So 3 times the 10 is 30. This is x to the, well, 48 divided by 6 is 8. On the bottom, this is obviously 1, so this is just 6. And then this is x to the 1/4. And finally, well, it won't be finally, but finally, as far as simplifying this, 30 divided by 6 is 5. Now, when I divide and the bases are the same, I subtract the exponents. So I'm really doing 8 minus 1/4. You can get a common denominator, or you can just use a calculator. The way that I like to do it is I would just do 8 minus 1/4 in the calculator and then turn it into a fraction by doing math enter, enter. That's in the TI-84. Or you just use a decimal, but it gives me, whoops, that's just a 5. And then it gives me x to the 31 over 4, which again, I know 8 is 32 over 4, so I could do it in my head or just use the calculator. It doesn't really matter. In this case, we're using fraction or decimal because it wants the value of a times b. So now we can see that a is the 5 and b is the 31 over 4. So I just multiply them together. So in the calculator, I'll just take what I had and multiply by 5. And it gives me either 155 over 4 Or if you wanted to give it as a decimal, you just give 38.75. Let me move this. So either answer is acceptable. So it's really just doing a lot of exponent laws after putting it in exponential form, and then just kind of basic multiplication. All right. So any questions? Good, good. All right, let's keep going at these problems. These are all like equivalent expression problems. Um, so let's take a look at number three. All right. I'm going to do this. I'm going to show you two different ways to do this. So the more mathematical way is we've really got to understand our exponent laws. And one of the exponent laws is when the bases are the same, we add our exponents. That's an issue here because the bases are not the same. So one thing you want to try to do, it's not going to work here, but it's worth talking about, is you want to try to make the bases the same. But the problem is nine is a power of three and four is a power of two. So we can't make them like kind of come from the same power or the same base. So that's not an option. So a lesser known, I guess, exponent law would be like if we had, if two things are both raised to the same exponent, then we can then multiply those together. Um, and the what we can do to manipulate this, that's why this one's a little bit more difficult, is I can rewrite this like this. This is going to look strange at first. Because when you raise a power to a power, you multiply. And 1 over 2 times 1 over n is 1 over 2n, so I haven't changed anything. The reason that this is beneficial is because 4 to the 1 half is the square root of 4, which is 2. So now I have a scenario where I have the same exponent. So when I have the same exponent, I just multiply the bases. 9 to the 1 over n times 2 to the 1 over n is 18 to the 1 over n. And then what we talked about on the last problem was how to change it. So this represents the power and this represents the root. So therefore, that is the square root of 18. So the answer ends up being C. So that's again a bit of a kind of higher level problem. Um, the other way that I would go about it is if you don't either think of that or if that's confusing, another option for this one would be to choose your own values. Uh, I would stay away from one here, but I could just do n equals 2, which means this expression is 9 to the 1 half times 4 to the 1/4. And I would just throw that in the calculator. I mean, 9 to the 1 half is 3, but let's say we didn't even really want to think that much. Just put it in the calculator. So 9 to the zero point 0.5 times 4 to the 0.25, maybe. And you get about 4.24. And then you just plug that into all of these. So like this one would be doing 24 to the 1 half, which is a different number. The other one is 12 to the 1 half, which is again like a different number. Then when you do the square root of 18, you get this exact number. And obviously the square root of 6 gives you something different. So it's just like a backup method to the actual math. So again, if this was either confusing or just on the actual SAT, if you're not thinking of what you could do to simplify, instead of just like wasting time trying to come up with something, in this one, you can just pick a number, evaluate the expression, and evaluate all these with that number and just see which one matches it. Good. All right, let's keep going. So this one. Okay. All right, this one's, I guess, a little more straightforward as far as like, there's nothing tricky about it, the way they're asking the question. It's just kind of a straightforward school problem. So Whoops, let me go down here. So what I would do first is there is a tricky part of it though. Whoops. All right, so let me write this. All right. So the way that you want to add fractions in general is you want a common denominator. And the way you get a common denominator, the way you can see how to get a common denominator is to make sure everything's factored. I'm going to factor an xy out of this. And if I take an xy out of this, I'm going to be left with an x minus 8. And now this is super important. What I see on this problem a lot of times is students do this and then cancel out the x minus 8. You're allowed to divide them out. You just don't want to because, again, think about your goal is to get a common denominator. Well, this has an x minus 8 in it, so I want this to have an x minus 8. What I really want to do is I want to give this an xy because that'll get us a common denominator. All right, so a lot of times they see the cancellation and then students just get stuck and then they're just like, the x minus 8 we want there. But again, it's typical SAT to have something strange happen like this where you can get a cancellation, but you don't want one. You want a common denominator. So that means if I multiply the bottom by xy, I multiply the top by xy. So then it's just straightforward distribute. I get xy squared plus 12xy. And then over here, I get plus yx, which is just really xy, and then minus 8y. And then I just have my common denominator. Then I would stop there. So you want to make sure you stop a little bit early on problems sometimes. So you're not just wasting time writing. I mean, at this point, we can figure out our answer. We have an xy squared. This combined is a 13xy. You don't need to write that out. That gives us one of these answers. And then I have a minus 8y. And then it's basically what is my denominator? And if I were to distribute this, it's just this. Like we already factored it. So that's why this denominator is correct and it ends up being C. All right, so you don't want to skip too many steps and risk like making mistakes mentally, but when you get to a point like this where all you're doing is combining like one like term, it's not really worth writing all that out. Just kind of looking at the answers to see which one works. All right, cool. So, okay, so another, again, most of these are that kind of same topic equivalent expressions. So I'll give you some time for that. Okay. Um, this one again, a little bit tricky. We got to basically make these look the same. Um, so I think what I'm going to do is take advantage again of that like power to a power rule. So like an example would be if I had like x squared to the fourth, we should know that that's x to the eighth. So when you raise a power to a power, you multiply. So what I want to do is make this look like something raised to the 3x, right? Because that's what I have here. But I need it to be equivalent to this. So I have to work with this. So I'm going to need a base of 4, at least to start. And what I want to do is rewrite this so that it's equal to this. So this is like 4 raised to something raised to the 3x. And these two things have to be multiplied, as in this case. So I'm going to make this a 6 because 6 times 3x is 18x. So I'm not changing this, I'm just rewriting it in a different way. All right, so 4 to the 6 to the 3x is 4 to the 18x. But now I've made it look like this. So I just got to figure out what 4 to the 6th is. So it's a big number, and 4 to the 6 in the calculator is 4,096. So 4,096 to the 3x is this expression now. So the k, that they're looking for is simply just the 4096. An Yeah. So, yeah, real quick though, another way to do it again, this is the more mathematical way, is if you get stumped on a problem like that, just again choose a value. This one I think is a good one that you could just choose one. Because if you make x 1, so if x is equal to 1, then this is 4 to the 18th. Let's see if this works. That's going to be a pretty big number, but then that'll equal k cubed. And if you were to do it in the calculator, you could just do 4 to the 18th, which is just some huge number in scientific notation, but the calculator will do it. And then you're just doing the cube root of both sides. You're just doing, right? That's how you would get k by itself. So if you do the cube root of that answer, it does bring you back to 4096. All right. So again, different ways to go about this. So you got the kind of the more mathematical way, and then just make x1 and you'll figure out what k is. And it'll obviously work for 2 and 3 or any value you choose, just um, not 0. 0 wouldn't work here. All right, let's go on to number 6. So we got another kind of radical exponent problem. All right, so um, this one, they're in radical form and the answer's in radical form. So it seems like it would probably make sense to stick to radical form. The problem is we can't multiply these because the radicals are different. And there is definitely a way to turn this into the 12th root. But I actually think it might be easier to do what I had said before, might not make sense at first, is to just use exponentials. So I would do this if you could do this pretty quickly. I'm going to use the calculator to help me too. So this is just x to the 3/4, as I said before, power over root, times x to the 5/12. And then we know that this is just going to be equal to x um, to whatever this is when we add these together. All right. So again, it is very simple to get a common denominator here. But if you don't want to worry about that, just go into the SAT, just be like, no, I'm going to use my calculator so I don't have any of these silly mistakes. You'll just do 3/4 plus 5/12 in the calculator, and then you do math enter enter again in the TI-84, and it'll automatically just reduce it for you. So you'll get x to the 7/6. Now this is super important. This 7 over 6 is not m over n. We've got to put it back in this form. So it's the 6th root of x to the 7th. That's like back in exponential or in radical form. Now m is what's outside. The m is the sixth, and the n is the 7. So like the answer to the problem is 6 over 7, which is a little bit confusing because like we got 7/6 here. So it's just what they assigned M and N. Um, just to go over the other way to do it, you can multiply radicals as long as they're both the same. So this 12x, the 12th root of x to the 5th is good. But this one, if I want to make this the 12th root, just imagine like getting an equivalent fraction. If I'm multiplying the 4 by 3, then I multiply the 3 by 3. So this is like x to the ninth. So like the 12th root of x to the ninth is the same thing as the 4th root of x to the third. And now you can multiply these to get the 12th root. And then I have to add, I got to do x to the ninth times x to the fifth, which is x to the 14th. But again, this is tricky because that's well, I guess we would have to reduce it. So the value of m over n would be m would be 12 and n would be 14. And then you'd have to reduce that because you got to reduce all fractions on the SAT and you'd just be left at 6 over 7. So I'm not saying that way is better, but It's again, that's a way to keep it in radical form. But I personally would probably just do the exponent way and just kind of let the calculator do the adding and then just figure out what m and n are. All right, let's go on to number 7. Okay, so we got to find m, and n squared is 9. Um, I guess you could just say n is 3, but I guess n could be -3. So rather than that, the way I'm going to do this is just kind of look at this as, like I was saying before, one of the main properties is when you raise a power to a power you multiply. So it's really 2 to the m plus n times n minus n. Well, hopefully this is a pretty common one. This is called a difference of two squares. If you were to do FOIL here, the middle terms would cancel out and you'd just be left with m squared minus n squared. So I have 2 to the m squared minus n squared equals 128. And then we just have to, I mean, you can use your calculator. It depends on how good you are with powers. We should know the powers of 2 probably up to at least 64, which is 2 to the 6th. So 128 is one past that, which is 2 to the 7th. But you just kind of use your calculator to guess and check. You may have learned logarithms, but you don't, logarithms aren't necessary for the SAT. So it should always be like a power of this number. So it turns out that 2 to the 7th power is 128. So we know m squared minus n squared is 128, but n squared is 9. So it's just m squared minus 9. I said 128, but I meant 7. Um, because 2 to the 7th is 128. So this whole thing should be 7. So m squared minus 9 is 7. Just pretty simple. M squared would equal 16. So therefore, m is equal to 4. And that's your final answer. All right, another equivalent expression problem. This one's a little bit tricky, so I'll give you a little bit of time. Okay. Um, I think the way that I'm going to do this one, we had talked about earlier, like how to square something out. So I think I'm just going to do that with this one. So when I do that with this one, I get x squared. All right. So again, in general terms, you square the first one, then you multiply them together and double it. Well, x times -2 over x is just -2. And when you double that, you get -4. Then you square the last term. Well, squaring this is positive 4 over x squared. So that's what this one gives us. Now I want to figure out which one of these gives us the same thing. So what I'm going to do is I am going to just figure out what, notice all of them have this to start. So I'm just going to write out what that is. That's very similar. That's actually x squared, right? Just the first one squared. Then when I multiply these two together, 2 over x times x is positive 2. And when I double it, I get positive 4. And then when I square this out, I get 4 over x squared. All right, so every one of these is taking this, doing something to it to get this. So we're really looking at like what happens to the +4 to make it a -4, and that's going to be by subtracting 8. So actually, it's the first one that works. So I kind of work at it from both directions. I expand this out, and then I just go through the common part of all the answers and expand that out and just kind of think about it logically that I must have to subtract 8 from this 4 to get to the -4. All right, let's keep going. I got 10 problems here, so we'll do two more. Okay. So in this one, just like before, in order to subtract fractions now, we need a common denominator. So a couple things that we're going to do is to get a common denominator, I need some, I basically, the denominators are completely different. So what I want to do is multiply this denominator by 2x minus 3, and then this denominator by x minus 4. But what really is, I want to do that in the numerators. So I want to multiply this one by 2x minus 3 over 2x minus 3, and this one by x minus 4 over x minus 4. And then what's going to happen is we have to realize that when we do 2x minus 3 times x minus 4, that is the 2x squared minus 11x plus 12, right? And you could do that, but I mean, it kind of has to be. So all the denominators kind of go away, and we're not really concerned with that. And then we just need to simplify the numerators and figure out what b and c are. So let's just kind of do that. In this first one, I distribute the x squared, and I get 2x cubed minus 3x squared. Now, this part is super important. There's a minus here. So I'm going to subtract and put a parentheses. This is usually the mistake. When you're subtracting a fraction, whatever I do with this multiplication, I have to distribute the negative to all that. So I'm going to do it first. So if I do FOIL, I'll get x squared minus 4x plus 12x minus 48. And then I'm going to do one more step. So 2x cubed minus 3x squared. I'm going to combine these and distribute the negative. So I'm going to get minus x squared. This is 8x, but I'm going to be subtracting it. And then I'm going to have a positive 48 because, again, I'm distributing the negative. And then I'm going to stop there because now I'm just going to look at it and say, okay, I need the value of b and I need the value of c. So here's again where we don't want to really waste too much time writing stuff out. B is the coefficient of x squared. Well, that's going to be what I get when I do negative 3 minus this 1. So this will combine to negative 4x squared, but I don't really need to write it out. I just want to know that b is negative 4. And c is the coefficient of x. Well, this doesn't combine with anything else, so c is just negative 8. And finally, it wants me to multiply them together. So the answer to the problem, whoops, is going to be 32. Negative 4 times negative 8. All right. Any questions on that one? Good. All right. We will do one more problem. Okay. All right. Last problem here. So it's telling me that one of the factors of this is x plus b. So we certainly could just try to factor it on our own. But I would rather not do that. The numbers are a little bit big. Again, that doesn't mean that it's like too hard, but we're really trying to save as much time as possible. So what I'm going to do to factor it is I'm actually going to use Desmos. But before I go to Desmos, I want to explain like how that would even work. So the idea is Desmos is going to give us a graph, right? Well, we need to understand the relationship between, let's say, an x-intercept and a factor. And basically, the way it works is whatever the factor is, when you set it equal to 0 and solve, that gives you the x-intercept. So for instance, for an example, not related to this, if you had an x-intercept of 3, your factor would be x minus 3. If you had like an x-intercept of negative 5, then your factor that went along with it would be x plus 5. Because again, if you set x minus 3 equal to 0, you'll get 3, and that's an x-intercept. If you set x plus 5 equal to 0, you'll get negative 5. That's an x-intercept. So these are not from this problem. I just want to make that clear. I just made these up. So what I'm going to do is I'm just going to go to Desmos and show you how we can quickly figure out what the factors are of this without actually having to factor it. So let me do that. And so I'm just going to put it in as is. So 2x cubed plus 42x squared plus 208x. and I'm going to look at its x-intercept. So negative 13, negative 8, and 0. So what that means is, so negative 13, negative 8, and 0. So that's the only information we need from Desmos are the x-intercepts. So I'm just going to jump back to the actual thing. And what that means is, so again, let's kind of forget about these for a second. If we have an x-intercept of negative 13, that's a factor of x plus 13. If we have an x-intercept of negative 8, that's a factor of x plus 8. Now, zero's tricky. Zero could have any number of factors. It could be x, x squared, 3x, 2x. I mean, in this case, it'll be 2x because if I look at this, I can see I could factor out a 2x. I'm trying to do it without actually factoring, though. But if I need the factor to be x plus or minus a number, then zero won't be part of that because zero will always have a factor of like just x with no plus or minus. So I almost can just ignore this. So I know these are the only two factors that matter. What's the smallest value of b? Well, my b values are 13 and 8. So the answer to the actual question is 8. So like once you understand it that way, you can do it really quick. You can just throw it into Desmos and look at the and know that the only way you're going to have a plus is if you have a negative x-intercept. So you just see the two negative x-intercepts are negative 13, negative 8, and 8 is smaller than 13. And again, that means that it factors to x plus 13 times x plus 8. I don't know, 13 times 8 is not like a common one that we see a lot factoring. So that's why I feel like Desmos could be quicker than like actually factoring it on your own. Yeah, so in general, you can't ignore it, but you can here because they told us that the factor was x plus b. So if the factor is x plus a number or x minus a number, in that case, you can ignore the x-intercept of 0. So in reality, if there is an x an intercept of 0, you can't just factor it completely on your own because that, like I said, this one ends up being 2x, but it could be 6x, it could be 7x cubed. They all would give you 0. But if you have numbers other than 0, they will give you the actual factors, um, especially when they're being specific like this. All right, so any other questions? All right. All right. Well, thanks for coming. Okay. Yeah, yeah, yeah. Definitely submitting problems helps. If not, I have a bunch of problems, but I'd rather them come from the students. If you know, this is always going to be free. So if you know anybody else that wants to join, then just have them email me and can get them on as well. And hopefully we'll have more students next week. But yeah, thanks for coming, and I'll just see you next week.